Hey there! If you've ever wondered about the difference between a load balancer, a reverse proxy, and an API gateway, you're not alone. These three components are fundamental to modern web architecture, but they're often confused with each other, and for good reason. They actually have overlapping functionality. Today, we're going to break down exactly what each one does, when to use them, and how they're different. Let's dive in. First, let's establish our baseline. In the simplest web architecture, you have a client making requests directly to a server. The client sends a request, the server processes it, and sends back a response. Simple enough. But what happens when your application grows? More users mean more requests. A single server can only handle so much traffic before it becomes overwhelmed. This is where our three heroes come into play, but they each solve slightly different problems. So let's examine each one, starting with the load balancer. A load balancer does exactly what its name suggests. It balances the load across multiple servers. Think of it as a traffic cop directing cars to different lanes. When a request comes in, the load balancer decides which server should handle it. It might use round robin, sending each request to the next server in line, or it might be smarter, sending requests to the server with the lowest current load or fastest response time. Here's the key benefit: high availability. If one server goes down, the load balancer detects this and automatically routes traffic to the healthy servers. Your users never know there was a problem. So in essence, a load balancer's primary job is distributing traffic and ensuring reliability. But here's where it gets interesting. Load balancers often include reverse proxy features. Let's talk about that next. A reverse proxy sits between clients and servers, acting as an intermediary. From the client's perspective, they're talking to one server. But behind the scenes, the reverse proxy is forwarding requests to the actual backend servers. Now you might be thinking, wait, doesn't a load balancer do that too? Yes, a load balancer is a type of reverse proxy. But a reverse proxy can do much more than just load balancing. A reverse proxy can handle SSL termination, decrypting incoming HTTPS requests so your backend servers don't have to. It can cache responses to serve them faster. It can compress data to reduce bandwidth, and it can provide an additional security layer, hiding your back-end infrastructure from the outside world. Think of Nginx or Apache as reverse proxies. They might forward all requests to a single application server, or they might route different paths to different services. For example, requests to /images might go to a static file server, while /API requests go to your application server. So while all load balancers are reverse proxies, not all reverse proxies are load balancers. A reverse proxy is really about providing an abstraction layer with additional capabilities. Now let's talk about the API gateway. This is where things get really interesting, especially in microservices architectures. In a microservices environment, you might have dozens or even hundreds of individual services. Without an API gateway, a client would need to know about all of these services and make separate requests to each one. That's messy and inefficient. An API gateway solves this by providing a single entry point. It's like a receptionist at a company. You tell them what you need, and they coordinate with the right departments on your behalf. But an API gateway does much more than routing. It handles authentication and authorization, making sure users have permission before forwarding requests. It can aggregate responses from multiple services into a single response, saving round trips. It provides rate limiting to prevent abuse, request transformation to adapt client requests for backend services, and protocol translation. Maybe your client speaks REST, but your backend services use gRPC. Popular API gateways include Kong, Amazon API Gateway, and Apigee. They're specifically designed for the complex orchestration required in modern API-driven architectures. And here's the key distinction. While an API gateway typically includes load balancing and reverse proxy features, its primary purpose is API management and orchestration. So let's bring this all together. These three components exist on a spectrum of functionality. A load balancer focuses on distributing traffic across servers for performance and reliability. A reverse proxy adds abstraction, security, and optimization features like SSL and caching. An API gateway goes even further, adding API-specific features like authentication, rate limiting, and request orchestration. In many cases, you might use multiple components together. You could have an API gateway handling authentication and routing, with load balancers behind it distributing traffic across your microservices. The choice between them depends on your specific needs. Are you just distributing traffic? Use a load balancer. Need SSL termination and caching? Add a reverse proxy. Building a microservices API? Consider an API gateway. Thanks for watching. If you found this helpful, don't forget to like and subscribe. See you in the next one.